Hello, good afternoon, good morning, good evening, depending on where you are today. I hope all of you guys are doing fine today. Everybody's healthy and you're in the mood for some BIM. In our webinar series, we have always tried to bring all the specialists here at the PointCab Special Weeks. And today we have our one and only Iulia Prica, my colleague from Laser Scanning Europe. And hi, Iulia.
Hi, Andrea.
And today she's going to talk about how much BIM is enough. And she's going to juggle between the costs and benefits and yes, of the BIM modeling in general. So I will introduce a little bit my guest today. Julia is working for Laser Scanning Europe, as I said, mainly in the service division of Laser Scanning Europe here in Germany. And she also has experience in CAD modeling, 2D modeling, and of course, BIM modeling. That's why, of course, we have invited her today as our guest in our webinar series. I think now she can tell more about herself. I will be on mute and I will just moderate uh, this webinar. Have fun.
Thank you, Andrea, for the nice introduction. I would like to welcome you as well to the webinar series from PointCab. My name is Iulia Prica, and I'm working for Laser Scanning Europe in the service department. My background is engineering. I have studied surveying engineering, and since 2016, I entered the laser scanning and modeling world. I'm happy to present you today this webinar, How Much BIM is Enough, between the costs and benefits of BIM modeling. And yeah, since we will talk about modeling today, I would like to briefly introduce the software solutions that we are using in our company. We are mainly working with the Autodesk products, so AutoCAD and Revit. For the point cloud evaluation, we are working PointCab and Scene. And yeah, since the modelers cannot go often on site, this is a very good way to visually see and process the point clouds a bit more compact. For special kind of modeling, we are also working with our partners from ClearEdge 3D. This is mainly used for piping elements or structural elements. Moreover, we can also work with solutions as Geomagic Design X or Arena 4D. Who wants to know more about the company? Yeah, you can just visit our website and read more about what we are doing. So yeah, with no further ado, I will go to our agenda for today. The agenda is divided as follows. So what does BIM means? Many of you, of course, have heard about it or already know a couple of stuff about it. Then I'll go to where we stand with the modeling in this whole BIM life cycle. Also, I will talk about the differences between 3D modeling and 2D modeling, since a lot of questions and requests are coming regarding this topic. And what is BIM in practice, and the fields of application, so where to find the BIM modeling, how to use them, then a bit about the classical and the parametric modeling, what are the differences here as well, and also about a bit more a closer look in the BIM modeling, talking about LOD, accuracy level, and the information densities, and then at the end, the exports of 3 modelings to other CAD softwares. At the end, just to give a small conclusion on the subject. So going further, what does BIM mean? So BIM stands for BIM information model, building information model, or building information modeling. So yeah, if you will search on the internet, you'll find a lot of definitions for this term. This definition is on our website. What a BIM, so a building information model, means is the 3D illustration of a building, which additionally is described with information. This can be seen in this scheme that I have inserted in here. The scheme describes the ND dimensions, so the degree of information that is in or could be included in a BIM model. And yeah, in the as-built modeling, so we are working mainly in the 3D geometry area, and yeah, less in the other ND dimensions for this definition. How does such a BIM model looks like? So at the beginning of a project, you'll need to start the project. Then you will have a coordination model, and at the end is just an empty model which describes the new construction plan or the path to begin. And little by little, these models of coordination will lead to the specialized models. The specialized models are, as you can see in here, can be the environmental model, so the digital terrain model, where it's all about the surface, or the surface is concerned. Then we have the building structure and mass model, and in this one, it's mainly about how the project fits into the urban planning. And after that, it goes into the individual specialized models, such as the construction site equipment, the architecture of the building, the supporting structure. Then, of course, the technical building equipment, such as electrical, communication, piping systems, the construction and assembly model, construction progress model, the documentation, and then in the end, the CAFM model for the company. In each BIM process, there should be a BIM manager who checks from time to time whether everything fits together, whether all these individual specialized models are coordinated to each other, if there are collisions in the models, and then the BIM manager should react in real time in the process and influence how this should go on. The next topic is the BIM life cycle, as said in the agenda. And here I would like to talk where we currently stand with the modeling and the scanning acquisition strategy. This can be very well explained in this life cycle of the building. So life cycle of the building begins with its construction and ends with its demolition. In between these two phases, the building will be rebuilt or extended depending on the requirements. Then, the BIM method helps in the planning and execution of this rebuilding. And then with the help of the BIM, the building can go back into operation more faster. Since we are mainly working in existing buildings, so we are not working in planning buildings, it means that usually the building is already built, is been used for a while, and now it's just a matter of planning the remodeling phases. And this is where scanning and modeling comes into the BIM process. And at the end, so after everything is done, the building will go back into operation. Moreover, in this loop, we can also talk about the facility management. So the BIM can be used in the operational phase, as I said, and more often we are asked by customers to create a 3D model for them in order to have a closer look and in order to be able to better manage the object or the building itself. Then the next point, so to explain more clearly what's meant with a life cycle, I have tried to distribute that in the service phases according to the architects, named HOAI. And yeah, for example, we have the service phase 0, which means the feasibility study, and yeah, this doesn't really exist in the literature, but since scanning and 3D models are already used in this area, I have also listed that in here. Then in the service phase 1, in the basic design, here is a bit more clear. It's more focused on the as-built determination using scanning and 3D models. Then the services phases 2 and from 2 to 8 are actually the construction phases, and I will not go into detail with that. And then in the end, we have the service phase 9, the project support and documentation. As mentioned in the life cycle, it's very interesting for a lot of customers to, in order to manage their assets. To give you some examples from practice and not just talk from theory, what are these service phases actually mean, and how this looks like in modeling area. So for the service phase 0, for the feasibility study, we can talk here mainly just about the point cloud visualization and these very simple models. So for example, in these pictures that you see in here, we have an example from a customer of ours, which he had designed a building as a replacement for an old one. Through the 3D model, he was able to show his team how the new one could replace the old one that has been about to be demolished. And he was able to reply to a lot of concerns like, how does the new building fit into the existing development area? What about the height? Does it fit in the urban planning? What are the dimensions of it? Which materials should be used so that it fits with the whole environment? What are the light and the shadow conditions, and so on? So he was able to convince his team very quickly and very easily that this building could fit in that place. Then about the service phase 1, the basic design. This is here is much easier to imagine that the example are used to determine the basis. Very often the classical 2D plans are still used, meaning floor plans, sections, or facade views. But more and more often our requests are coming for 3D models, and here is, for example, a combination between the terrain model and the urban planning model. Then in the service phase 9, the project documentation and supervision, as mentioned before, it is often found for facility management that they need a 3D model in order to see exactly what the as-built stand of that building is. So we can see that the 3D models can be used very flexible, and that modeling and scanning can be always found in the entire BIM process. Then going to the next point, 3D versus 2D modeling. Does it always have to be a 3D model? Of course, a lot of questions have arisen. Why aren't the 2D plans still all right? They have been used for in the past, over many years, and they have they are proved to be good and to show the situation on site. The 2D model doesn't have to be necessarily worse than a 3D model. It depends on the application, and it depends what exactly the customer requirements are. Exactly for this subject, we have on our website a case study where you can find more information about it. I will just talk about a couple of points from this case study in case you want to read it and to go a bit more into detail. You can just go on our website and you'll find the case study there. For the webinar, as I said, I have only taken a few points. Talking about the basis of 2D or 3D modeling, they are basically the same. We can use hand measurements, we can use surveys, we can also use scan data from laser scanners and drones, also pictures, images, or even old plans of the building. It always makes sense to basically combine all these means, all these methods, and to be flexible and integrate additional information from one or another as-built plan into the model. The major differences between 2D and 3D in further processing, the first one that I'll talk about is the accuracies and standards. In 2D modeling, the standards and accuracies have been already very good established. We can talk here about DIN regulations, control values. These are very well-known terms already that both modelers and customers know. And they can use in order to define their requests. And basically both the customer and the modeler are speaking the same language. When it comes to a 3D model, though, it's a bit more complicated right now because the 3D models and these BIM standards were mainly made for planning projects for new buildings and less for existing buildings. Therefore, these standards and the LOD that are defined are not always so clear. Then the next point will be the measurements true to deformation. So here is also quite a big difference. In the 2D modeling, we can we are going to create sections or layouts at a defined position, and it's very easy to create these plans according to the deformation. So we can draw, for example, an inclined wall, or we can draw very easily the deformations that we see in the scans. On the other hand, when using 2D modeling, you will only have these deformations in the place where you created the section. So if you're going to move a bit, if you're going to do a parallel section or a parallel plan, then the deformations will be different. And in order to show that on the plan, you'll need to start over, so to make a new plan at that specific height. When it comes to 3D modeling, then a model, in this case, a model remains a model. It's very hard and very time consuming to model completely, so geometrically exact. So to create a complete deformation compliant model, and this should be actually discussed before with the customer as well, if they can work in specific tolerances, and define the standards that might include both, so a little bit of the deformations and a little bit of generalization. a good method here is to actually combine the model with a point cloud and see where exactly this deformation, how does it look in real life. Then the next point, the plan derivations. So in a 3D model is relatively simple. You have already the model, and then you can just create a plan in the desired location. It's not necessarily to discuss that from the very beginning. You can also, at the end of the project, can also move or create very easily and very fast a section or a plan. Whereas in the 2D plan, in the 2D modeling, when creating the plan derivations, one must know from the very first beginning where the section or the floor plan should be positioned, because each of these floor plans or sections are being drawn separately, and the position have to be defined in advance. When if it comes to changes or additions, it will require a lot of rework, and meaning that means or translates to more costs and more time. Also in the 2D, so another difference here in the plan derivations. In the 2D, most of the time the plans are very detailed. A lot of information can be presented in the plan, whereas in the 3D there is not as much information in the plan, and the customer could say, okay, this is not what I expected. But lately this is changing a bit, since as I said, the combination between the point cloud and the plan can be used in order to see very specific details. Another essential difference between the 2D and the 3D modeling is the output of component lists. So here, for example, we can just take windows or doors. In the 2D modeling, these component lists are usually created manually and handed over as documents like Excel or Word files. In this process, duplications or other errors always or often comes in between. Whereas in the 3D modeling, these component lists can be generated automatically, and then the error sources will be minimized. Another point is the clash detection, the collision analysis. For 2D here, like the 3D modeling has definitely an advantage. With a 2D plan, or even more 2D plans, is quite impossible to do a complete collision check, because only certain areas are shown and the whole building is not considered. Then the detection of these collisions only by lines and heights require a very high degree of knowledge of the situation on site. Whereas, with the help of the 3D model, the collisions can be often eliminated, and it's very easy to find the points where different objects might clash. In addition to the collision check, in connection to that is also the visualization. In the 2D plans, the spatial presentation of a building is quite difficult to be made. So for visualization purposes, sketches are made, maybe some pictures can be rendered, but the 3D model is basically perfect for visualization, and in combination with a point cloud, the customer can see exactly how the area look like, and also can do further planning. Moreover, um, with the help of the VR technology, the customer can actually move through the model and understand much better what is everything about. As I said, yeah, more points have been evaluated in the case study. So like the component libraries, the planning basis, the evaluation time, you can read everything about that in the case study on our website. To go to the field of application for BIM, where do the 3D models find their application? So in the field of architecture or real estate, maybe here you can see different images for different projects. Maybe one of them is like the most interesting one is the theater. This is also it was a project that our customer wanted to do, and for us was like, yeah, what's that for? So yeah, since the theaters have a lot of guests, some of them, they are bringing their own equipment, and yeah, this can lead to different issues. So yeah, the customer just wanted a model, so to give that prior to their guests and see how the stage design can be realized, how is the lighting technology, what are the space conditions like, and a lot of other questions that can be easily answered using a 3D model. Another field of application is the specialist planning. So for industry, for piping system, wastewater, we are receiving more and more requests for the creation of user-specific data. Usually, these technique rooms are very full, and they have a little space to expand or to plan something. And the projects that my colleagues are usually working on, it have as a purpose, the main purpose, remodeling. They only want to see what are the space conditions, if where are the collision points, if there is any space for new objects in there. Another field of application would be the infrastructure models for streets, bridges, or facilities of the rail works. At the moment, our colleagues are working on a project where a highway is being expanded. The client has the node points in the, wants to have all the node points and the route modeled. And the new highway has to pass through the existing bridge structures, and that is why the bridge structures have also been included in the BIM process. In the area of the road, of modeling the roadway, this BIM model has also been used for the quantity determination in the excavation, and also the areas next to the roadways went again to the new planning, and for possible further expansion. Another field of application, as I mentioned before, the facility management. I mentioned about that in the life cycle, the BIM life cycle. This is, as I said, this is becoming more and more popular, that the customers request their management of the building using a 3D model. In this example, we have a school, and in this case, so there are more and more students in the building, and more space is needed, and using a 3D model is quite easy to see how the space can be optimized, how are the access routes, and a lot of other observations that can be made using a 3D model. Then for the exhibition stand construction and event planning, here is mainly about visualization, especially in the event planning. So the customer can see, all right, what is that for a location? What kind of event can be made in here? How does it work? How can we optimize certain areas? The building envelope plays always a big role, and you can plan with the 3D model, you can plan all these events. The other example, so for the exhibition stand construction, also the exhibition builders can use the 3D model in order to be able to plan the exhibition. So in order to determine the locations of individual exhibitors, to calculate cabling and so on. So yeah, as you can see from all of these examples, the 3D modeling has a very wide range of applications. Now going to the next point. So as I said, I'll talk a bit about the classical and the parametric modeling. What does this exactly means? So in the classical or direct modeling, this is mainly focused on pure geometry. So you can, imagine like a sphere or a pyramid, or this kind of very simple 3D objects. These objects are represented by surfaces and solid models, and you can always change their geometry using the CAD software tools like scaling, rotating, stretching, and this kind of modeling is basically used for as build modeling and can be done very quickly and easily. And they are basically they are meant for very complicated models where the where the objects have to be captured realistically, and there is no need for dependencies with other objects. For the when it comes to the parametric modeling, here things are getting a bit more complicated. In addition to the geometry, their parameters will be added, or attributes will be added to the objects, and also these objects have dependencies between each other. So for example, for an object, we can add the material, the dimensions, the colors regarding the dependencies. So you can think about it like a window is depending on the wall, railing are related to the stairs, or fittings are related to the pipes. If I'm going to remove a wall, for example, the window or the windows that were placed on these walls are going to be removed as well. So change in the main element will result into a change in the sub element. Unlike the direct modeling, this requires the more experience to create a 3D modeling. So you will be starting with a sketch, and then the geometric parameters are added, like height, radius, rotation, and you can assign a lot of other additional attributes, and every object can be created or for every object a unique model can be created. So in practice, it's not working on either or principle. It's most of the times a combination between these two types of modeling is made in order to uh, yeah to um, to do the 3D model. Now, going a bit more deeper into the BIM modeling, the LOD. So the LOD is the level of detail, and it's basically describing the geometric requirements for different components. And it specifies for the modeler as well, for the customer, how detailed the construction element should be modeled. Also here, if you are going to research, you are going to notice that the LOD and the BIM strategies were developed mainly for the new constructions. So here we have all of the LODs and also their description. In practice, so yeah, these are the theoretical descriptions of each LOD. In practice, however, this is not so easy to define. We have here two examples. So when modeling facade elements, you can see the difference between the LOD, the different LODs, so 100, 200, 300, 400, and yeah, the same for the flanges of a pipe. This, so yeah, geometrically this can be quite quickly classified, but when looking into the description of the LOD, taking for example the LOD 300, the approval model, it states here the representations with exact dimensions, materials, and positioning. So yeah, also in this case, so yeah, the dimensions are correct, the positioning is correct, but how about the materials? It's quite difficult most of the times to define the materials, since the modeler is not usually going on site. Maybe we are working with scan data, or maybe even the surveyor has been on the site and had a look on all these details. However, it's hard to visually estimate what kind of material has been used, or for pipes, for example, what inner diameter it has, what pressure rating it has. And all of these questions cannot be answered by the modeler. And this is the essential difference between modeling for planning purposes or modeling existing buildings. When modeling existing structures, this LOD is often or cannot be often filled only by the modeler. Um, so the modeler will, of course, be able to describe the exact geometry and positioning, but maybe afterwards an expert could come in and complete all the other LOD requirements with the missing information, which the modeler cannot take out from the scan data. Talking about accuracies and level of detail, most of the times when the customers are calling and when we are discussing, they want everything as accurate as possible. But is that realistically advisable? So when there are some examples that when considering these accuracy requirements from different perspective, we reach the conclusion that this is not always the best decision in every case. And as in every project, good consultation in advance often changes this statement, and then the accuracy requirements are being balanced to the effort and benefits. So there are some customers then that are saying, okay, I don't need this model as accurate as possible. It works when it's in certain tolerances, and then it will actually reduce the costs and the time needed for modeling this kind of for modeling an existing building. We have here two examples. So I'll show you two examples of what we mean with this as accurate as possible. In this example, you can see, so it's about the sagging of pipelines. This is, you can always find this in old facilities and pipelines. And here the question that arises is, again, should these deformations be modeled or not? Is this information important or not? So you can see here that the first model is a generalized piping system, and then the second one has been made using single parts for each deformation. Most of the times when splitting a model like that, it will be as in reality, but it will be more hard to work with it further. And then at the end, the customer is saying, okay, I didn't imagine that this will be so hard. And all the time involved in that will be actually for nothing. And then a generalized piping system will have to be made anyways. So again here, consultation before starting the project is always very important in order to specify what exactly has to be modeled and how much does it has to represent the reality. Then the second example we have here, a lot of fittings. This is always a challenging task to model various fittings and pipelines as built, because there are a lot of cases where there's a sequence of various components and they can only be modeled to a specific extent using the native families from AutoCAD Revit. And without changing or modifying these elements, there is basically impossible to represent these elements as in reality. Also, if choosing to do the adjustment, then this takes a lot of time. And again, it's very important to clarify how relevant it is for the representation. You can see in here the comparison of the model and the point cloud. You can choose to place some general fittings, so not exactly as built, and then specify that in the documentation. Okay, in this place and in this place, the objects haven't been represented as in reality, so please turn on the point cloud in order to see what exactly is in there. So here is also important which information and level of detail the customer needs for this model. If everything has to be modeled, or if using these generalized fittings is enough. So as I said, this accurate as possible, saying it's not the best decision in every case. And as also already mentioned, consultation in advance always changes or often changes this statement. And then the accuracy requirements are balanced between effort, cost, and benefits. And most of the times, a combined solution is the best choice, which brings the best results. So as mentioned before, next to the model, use the point cloud as well. So in this example, when it was scanned, or when the modeling was done, there was still a construction time, a construction site at that point of time. And in this case, the construction site quantities were not modeled. They were modeled according to the average height of the surface. And again, here the documentation can be very useful, where you can send all this information to the customer and tell him, okay, this information you can find in this specific plan, or please use the point cloud in order to see specific details. Another very important point here, there are a lot oftentimes different media come together. So for example, drinking water, cooling, heating, electrical engineer, and yeah, what does the modeler, how much of all this information does the modeler has to know? So yeah, for example, we have here various fittings for the piping system, and okay, we can say, yeah, this is a pump, but do we also have to give in the type and the construction class? Or yeah, for the pipeline, do we also need to specify the inner diameter or the pressure rating? Or yeah, for each element of this piping system, do we have to specify all of these details? And yeah, from the experience, it's advisable that all of this information will be specified or verified by the appropriate experts. With a parametric modeling, the components can be described and specified clearly. And as I said, the libraries offers most of the times a variety of accessories, but the decision which type it's 100% the right one, it's very hard to yeah, to define. The most important part of the modeler in this step is basically the geometric LOD, so to represent that as accurately as possible from the geometric perspective, and then the technical details can yeah, or should be rather added by the professionals in a later step. Also, yeah, in this case, a good idea is to work with the so-called dummies, where you can specify, okay, this is a gate valve or this is a pump, but the type or the pressure class or every other details have to be added in a later step. Also, you have to be careful with certain models. So there there are a lot of models that have been already created by the producer, but yeah, they are very, very complex, and then when bringing them into the model, it will lead to slowing down the system, and maybe also for the further processing, it will be very hard to work with it. So yeah, again, all this information that can be taken out from the point cloud, um, it's again a matter to discuss with the customer if that information is actually needed, because most of the times, yeah, you can just load the model with unneeded data, and it will be it will become very very hard to work with it. Then talking about export options, so the IFC exchange format. Um, so when sending over the models to the customers, we are usually using this IFC exchange format and in this all the geometry data as well as the attributes and the classifications can be found. However, depending on the CAD software that you're using, it might be that the model cannot be um, further edited in the CAD software. So yeah, it also can be that when imported into another CAD software, part of that information is being lost. For that, yeah, it's very hard to understand what the model should be used for. So if you need to direct import it to further process of the data, or you need it just for visualization, or what exactly um, is the model for, then yeah, in the company, it's usually a project report is being made where a lot of information is being given to the customer regarding different attributes or different objects that can be found in the model. So that's because most of the times the end user never talks to the modeler, and without the project report or without all this information that we provide the customer with, it would be quite difficult to actually understand what's in there. Also, of course, the communication is always important between the end user and the modeler. There are also a couple of softwares that can be used for model checking, where you can check the geometry of individual objects. So if the object has been closed, and other stuff that you need or have to check. And now going to the conclusions. How much BIM is enough? So that was the question of this webinar. This is basically determined by the client. The client is always taking into consideration the cost and the benefits. So they will say what LOD do they need depending on how much they are willing to spend. And also how fast does the model has to be done. Again, the communication is very important. The W questions, which we have to ask the customers prior to starting the project. What exactly is the information that the customer needs? What is the model going to be used for? What is the purpose of the project? Do you need it for the visualization? Do you need to process this model in another CAD software? What kind of objects do they have to be need? What are how much are you willing to invest? And all these questions have to be clarified prior to the starting of the project. Then talking about the processing and the level of detail, it is recommended that accurate and usable geometry models are made. So, for example, if the first requirement was a BIM model with an LOD of 100, then it would be very hard to in case any changes has to be done or a higher level of detail is needed, it would be very hard to change that, and it might be that the project has to be started from the beginning, meaning that all the time and money are lost, and we have to start all over again with the new requirements. Then the idea of placing parametric 3D models with dummies for the expertise section. So as mentioned before, for very special objects that you need to place in the in your model, and you don't know exactly what kind of parameters this should have place these so-called dummies, and then let the experts fill in all the missing information. And then, as the final conclusion, the 3D modeling of as-built objects makes it possible to enter the BIM process from the very first service phase, and through a project agreement before the start of modeling, standards and evaluation strategies can be discussed and defined. So with that, I am at the end of this presentation. I would like to thank you for your attention. For any questions that you have and cannot be answered to you now, you can write us as dresden@lasenscanning.-europe.com. And I would like to now give the word back to Andrea.
Thank you very much, Iulia, for this quite long presentation and very interesting, in fact. Well, what I took from your presentation is that, well, time is money. We all know that, but when it comes to BIM, more time is, of course, depending on the customer. You already say that on the customer's wishes, but more time and more LOD does mean a lot of or more LOD does mean a lot of time spent on a project, and it really costs money. It can be expensive.
Yeah.
Well, I don't see now a question in our question box here. Maybe I will give you guys some time to yeah, write your questions. So I would have a question right now. It's kind of like, let's say, related to your company. Um, I do know a lot about your company. We're kind of like we're working together, and I do hear about projects like in general. But my question is like, um, I know that you guys are working also in CAD a lot, in 2D,
Mm-hmm.
and you have also this 3D department where you're doing, yeah, BIM
Mm-hmm.
stuff there. So in the last, let's say in the last time, did you get more projects that you have to model just in 2D or in 3D? Is there I don't know, some kind of correlation of a
Yeah, I
percentage?
think it depends on the customer requirements. I think we still get a lot of requests for 2D modeling, but depending on the project, it might be that is actually um, yeah, that it's more that the 3D model is more reliable. So if we are taking the example of a building with multiple stores, if yeah, we need to make, let's say, 3 floor plans, two sections, two vertical sections, and then also um, to draw, yeah, to create all this 2D facades view. It would take, let's say, approximately 40 hours. And then for, yeah, for an experienced modeler like we have in our company, creating the 3D model will take more or less the exact amount of time. So yeah, this can be also one of our decision depending what we find it better to do. But yeah, of course, for, yeah, for bigger projects might be different.
Okay, thank you so much for answering my question. Well, if there are no further questions, I will end the webinar for today. Thank you again very much that you found the time to be with us today, Yulia. Um,
Thank you for the invite.
I wish you a great afternoon or evening, and hope to see you soon. Bye bye.
Thank you. Bye.